This is the first lesson for Chapter 20 for Section 20.1. Chapter 20 deals with analytic geometry. If you haven't dealt with analytic geometry, this is essentially putting algebraic expressions and equations along with geometric shapes. So we're going to look at specifically circles, ellipses, parabolas, and hyperbolas. Now you've done this already with parabolas, lines, triangles, things like that. Now we're going to look at some things that you might not have seen before, specifically circles, ellipses, and hyperbolas. When we're dealing with a circle, we're going to look at the center and the radius. For parabolas, we're going to look at a vertex, directrix, and focus. When we're talking about ellipses, we're going to look at the vertices, the foci, and the lengths of the major and minor axes. And if we have time, we'll talk about the translation of axes when you're sketching graphs. So first things first, let's look at section 20.1, which is the circle. We're going to go into the introduction of what a circle is, and specifically to look at what a conic section is. So a conic section has the following formula. You've got something x squared, x times y, something times y squared, something times x, something times y, and some other constant. Now technically any of these could be 0, but we definitely need at least an x squared or a y squared if we want to deal with the conic sections. For the purposes of this class, we are not going to be dealing with the BXY, that's the translation of axes piece. The reason we call these conic sections is because we get these shapes when we split up a cone. And so if you look here, we've got a cone. Technically a cone would go in both directions here, so you see the little bit of that one there down below. But if you think about this, if you were to do a cross section and cut this cone, you would get a circle, and so that's going to be our first shape that we deal with. If instead you cut that cone on a bias, say through here, you would get an ellipse. If you cut the parabola, so notice that the ellipse here we were cutting through both sides. For a parabola, we would get this if we actually went parallel with the side of the cone here. We would get a parabola. Because you can see here how you would get the rounded part down here, and then it would go off to infinity in both directions. And then finally, if we were to cut straight down through and hit two pieces of the cone here, so in this case we are running parallel to the axis of symmetry, the thing that this is rotating about, we will get what is known as a hyperbola. And a hyperbola is going to be essentially two parabolas kind of opened up in opposite directions. So if you wanted a summary of what each of these shapes look like as far as an equation goes, and we'll come back to this in 20.6, a circle is going to have the form ax squared plus cy squared plus dx plus ey plus f equals 0. And in this case, a is going to equal c, so those coefficients on x squared and y squared are going to be equal. If instead we have an ellipse, we're going to have that same form, ax squared plus cy squared plus dx plus ey plus f, but a is not going to equal c. So we'll see how that affects the ellipse being essentially a stretched out circle. All of these are going to have this same equation that we've listed here. For a parabola though, either a equals 0 or c equals 0, but not both. And for a hyperbola, so that's the one that we might not have seen before, a and c have opposite signs. So one is positive and one is negative. So that's kind of a summary of what all these are going to look like, and we'll come back to that in 20.6. So for right now, let's just take a look at the circle and talk about what a circle is. A circle is a collection of points that are equidistant from a given center point. And we'll talk about how you can find that center point. The radius is the distance between the center and the edge of the circle. So this is something that you should all be familiar with. You've dealt with circles before. We've talked about how when we were dealing with the unit circle, how we can rotate around and how we end up with a radius. So now we're just kind of saying in general what a circle will look like as far as if we put an equation to it, and a non-trigonometric equation, but you will see how this kind of falls in with trig a little bit. So let's look at an example. We're going to graph a circle that is centered at 0, 0, so the origin, with a radius of 1. So if we have a radius of 1, and this one isn't really drawn to scale real well, so I'm going to adjust it so that we are centered on the scale. And so this is something to keep in mind, especially when you're trying to do things in your calculator, that your calculator will not always draw things to scale and everything's rectangular. So if we look here, we've got, this would be about the same as if we had 1 here and here, so we're going to kind of get rid of our units here because they're not real accurate. And we're going to replace them. We're going to say that this is 1 and this is -1. So if we were to go through and draw a circle, it would be centered at the origin, and then it would just go around and hit 1 and -1 everywhere on each axis. So we'd hit 1 and 1 on the positive x and y axis, -1 and -1 on the negative x and y axis. So I want you to pause the video here and try example 2. So for this one, again, if you kind of adjust the axes to make sure that everything's square, you would have found that your center here is up here at the point -1, 2, and a half, and then if you go out with a radius of a half, it's usually kind of easier to go out in the axis direction, so you'd go down a half, up a half, and then to the left and right a half, and then draw that circle all together. So this is going to conclude the first video for section 20.1. The next video will look at the equation for a circle.